This is Rational Functions, Part 1. And if you're following in the book, this is the first lesson on Section 4.5. So we're going to start by defining what a rational function is. And a rational function is some kind of function that has a polynomial as a numerator, polynomial on top, and on the bottom of the fraction, a polynomial as well. Okay, and in case you forgot, polynomials are basically strings of terms that may involve, say, x cubed, x squared, x, and a number, or only a couple of those, or just one of them. Some examples might look something like this. Maybe we have as a function, let's see, y equals, we might have something like 3x squared plus 2x minus 1 as a numerator. And as a denominator, we might keep it pretty simple, maybe just x minus 7. Okay, that would be an example of a rational function. Or another one might be very simple, might just be a 2 on the top, and maybe we just have an x on the bottom. Okay, so they generally, as long as there's a polynomial of some kind on the top and the bottom, you have a rational function. So what are we going to do with these rational functions? Well, the first thing we want to do is look at if there are any restrictions. So that's kind of first important thing. Now, like any fractions, restrictions occur. A bad situation with any fraction is if you try and put a 0 on the denominator. This is considered bad. Okay, if you take your calculator and you go 7 divided by 0, you'll get an error message. Okay, it's considered undefined. Okay, this is simply not allowed. So this is, when we say restrictions, we simply don't want this to happen. So if we look at an example, if we have a rational function, maybe it looks like this, 3x on the top and x minus 2 on the bottom. We don't really care what happens with the numerator. The top can turn into 0, that's okay. But where it's bad is if the bottom turns into 0. So our restriction here would be x is never allowed to equal 2. And that would be a problem if x was 2, because 2 minus 2 becomes 0. So this is our restriction. Let's look at another example. Okay, maybe we have as our function x squared plus 2x on the top. And on the bottom, maybe we have something like 11x. Okay, again, all we want to focus on is the bottom. When is that ever turning to 0? Well, if x was 0, we would have a problem. So our restriction is x is not allowed to be 0. Okay. Now sometimes there's no restriction. What if you had something, say, like this? Maybe a 10 on top, and maybe you had as your bottom polynomial x squared plus 2. Okay. Well, the only way you could make the bottom, the denominator, become 0 is if you took x squared and somehow turned that into negative 2, so that when you went plus 2, they would cancel and become 0. So the question is there any way to take x and turn that into negative 2? Question. Well, the answer is no. Okay, you can't square a number and have it turn into a negative. Okay, when you square a number, it's going to turn positive. So this doesn't happen. So there simply are no restrictions. Okay, everything is good for this rational function. Okay, so that's the world of restrictions. What I'm now going to do is take a little bit and have a look at what a basic graph might look like. So I'll put on the right side here so that we can sketch the grid. So I'm going to take a really nice, simple example. The most basic rational function I can produce, which is y equals 1 over x. And what I'm going to do is build a table of values. Okay, just to kind of get an idea what the graph might look like. I'm going to put a lot of points in here. I'm going to put in, say, -2, maybe -1. I'm even going to put in -0.5, okay? And I'm going to try to put in 0, maybe +0.5, as well as 1 and 2. So quite a few points here. And let's just see what the y values are. So 1 divided by -2 would just be -1/2. Okay? And we plug in -1, we get 1 divided by -1, which is -1. 1 divided by -0.5, if you do it on the calculator, you'll actually get -2. Now, when you go 1 divided by 0, you're going to get error or undefined. Okay, so this is not obviously going to be a point. If we plug in 0.5, 1 divided by 0.5, you should get +2. 1 divided by 1 is 1, and 1 divided by 2 is 1/2. Okay, so now we've got our table of values ready to go. Let's bring up the grid, and let's start plotting some points. Okay, so we're going to start with -2, which goes down to -1/2, right about there. We've got -1, 1, and we have -1/2, or -0.5, goes down to -2. Then at 0, there's this undefined happening, which I'll explain in a moment. Then we have 0.5, +0.5 goes up to 2. And we have 1 and 1. And then we have 2 going up 1/2. Okay? Now we could do more points, but you'll just have to trust me that this is basically what the graph is going to look like. Okay, you're going to get these curved sections that kind of, my hand's not very steady here, but anyway, it's supposed to be nice smooth curves that go like this. Okay, and you get kind of the same thing happening down here. So we'll try to draw that as steady as I can here, something like that, and then here's something like this. Okay, so you got kind of these two sections with this little break in between here. And I'm going to explain what's going on in this in-between part, the y-axis, and also on this one you have this kind of break horizontally here, this x-axis break. What you have happening there are called asymptotes. So I'll just spell that for you, asymptotes. Okay, and this one here, maybe what I'll do is try to change colors here and show you in red. This guy here is a vertical asymptote. So try to draw a line down here, so something like that. And what the graph tries to do, as the graph goes higher, it gets closer and closer to the y-axis, but it never touches. Okay, same thing happens down here on the bottom side. The further down we go, the closer we move towards the y-axis, but it never touches. And the same thing is true, and I'll just draw the horizontal asymptote here. Okay, this guy here, the x-axis, is our horizontal asymptote, and both this section here, it's actually approaching that line. It's getting a little bit higher as we move to the left. It's trying to kind of get closer to that line, but it never touches. Same thing is true over in this zone. It keeps dropping, but it never actually touches the x-axis or crosses or anything like that. Okay? In a way, the vertical and the horizontal asymptotes, they kind of frame in the graph. They kind of give it these little lines that the graph snuggles up to. Anyway, that's probably enough for part one, just to introduce the rational functions and what a graph of a rational function has. And we're going to just continue on sort of graphing and showing you some tricks how we find the vertical and horizontal asymptotes when we get to part two.